Welcome to your Mentor One. In this video, let's discuss about the classification of transformers on different bases. Depending on whether they increase or decrease the voltage, transformers are classified as either step-up or step-down transformers. Both step-up and step-down transformers operate on the principle of Faraday's law of electromagnetic induction. They consist of a magnetic iron core wrapped with two sets of coils, which is primary winding and secondary winding. In primary winding, the coil is connected to the input power source, and in secondary winding, the coil is connected to the output load. The change in voltage depends entirely on the ratio, that is, the ratio of the number of turns in the primary coil to the number of turns in the secondary coil. First one, step-up transformer. A step-up transformer increases the voltage from the primary side to the secondary side. The secondary winding has more turns of wires than the primary winding. As the voltage is stepped up, the current is simultaneously stepped down to maintain the conservation of energy. It's mainly applicable in power generation stations. 2. Step-down transformer. A step-down transformer decreases the voltage from the primary side to the secondary side. The secondary winding has fewer turns of wires than the primary winding. As the voltage is stepped down, the current is stepped up. It's mainly applicable in distribution substations and service transformers. According to the construction, that is, based on how their core and windings are arranged relative to each other, transformers are classified into two as core type and shell type transformer. First one, core type transformer. In a core type transformer, the windings surround a considerable part of the magnetic core. Construction. The core is typically rectangular. The windings are given the form of concentric coil that is usually cylindrical and are placed on the two vertical limbs of the core. To minimize leakage flux, half of the low voltage winding and half of high voltage winding are placed on each limb, with the LV winding placed closest to the core for easier insulation. It features a single magnetic circuit. It's mainly applicable in power and distribution system. Second one, shell type transformer. In a shell type transformer, the core surrounds a major portion of the windings. Construction. The core usually has a three-legged structure. Both the primary and secondary windings are wounded around the central limb only. The windings are arranged in a sandwich fashion where layers of HV and LV windings are alternated along the limb. It features a double magnetic circuit. The flux generated in the central limb divides equally and returns through the two outer limbs. It is mainly used for industrial purposes. According to the number of phases, transformers are classified into two as single-phase transformer and three-phase transformer. Both single-phase transformer and three-phase transformer are crucial for stepping voltage up or down in electrical systems, but they are built and utilized quite differently based on the power requirements. First one, single-phase transformer. A single-phase transformer operates on a single-phase alternating current system. It consists of a magnetic core and two windings, a primary winding and a secondary winding. How it works? Alternating current flows through the primary winding, creating a varying magnetic field in the core. This magnetic field induces an AC voltage in the secondary winding. Voltage system in single-phase transformer typically distributes power using two wires, one phase and one neutral. Common applications: residential homes, small businesses, and light commercial appliances. Second one, three-phase transformer. A three-phase transformer operates on a three-phase AC system, which is the standard for global power generation and transmission. It can be constructed either by combining three separate single-phase transformers or by winding three sets of primary and secondary coils into a single integrated three-leg magnetic core. It handles three distinct AC voltages that are sequential in time, separated by a phase angle of 120 degree. Winding configurations. The winding can be connected in two main ways, that is delta and star. Delta is a three-wire configuration where the end of the transformer are connected in a closed loop. Star is a four-wire configuration where one end of each winding connects to a common neutral point, providing both line to line and line to neutral voltages. Common applications: industrial manufacturing plants, high voltage power grids, data centers, and heavy commercial power distributions. Transformers can be classified into several distinct types based on their specific application and whether they are deployed in an electrical grid or industrial system. First one, power transformer. Power transformers are designed to operate at full load with high efficiency in heavy-duty applications. They are typically used in transmission networks to step up or step down high voltages, usually about 33 kV. It is applicable in generation stations, transmission substations, and receiving grid stations. Second one, distribution transformers. Unlike power transformers, distribution transformers operate at relatively lower voltage, usually less than 33 kV, and are used to deliver usable voltage directly to end consumers. It is applicable in residential neighborhoods, commercial buildings, and light industrial areas. Key features: they are designed for high efficiency at lower load. Because they remain energized 24/7 but rarely operate at full capacity simultaneously. Third one, current transformers. Current transformers are used to step down high primary currents to a standard manageable level for ammeters, wattmeters, and protective relays. Key feature: the primary winding is connected in series with a power line. Fourth one, potential transformer or voltage transformer. Potential transformers are used to step down high voltages to a safe standard level, typically 110 watt, for wattmeters and protective equipments. Fifth one, isolation transformers. Isolation transformers are designed with a 1:110 ratio, meaning the input voltage matches the output voltage. Their primary purpose is not to alter voltage but to decouple two circuits physically. It is applicable in sensitive electronic equipments, medical devices, and laboratory instruments. Sixth one, autotransformers. An autotransformer features on a single continuous winding wound on a laminating core which serves as both the primary and secondary winding. The voltage is stepped up or down by tapping into different points along the winding. It is applicable in interconnecting power systems operating at similar voltage levels, starting synchronous or induction motors, and in testing laboratories. Key features: they are more compact, lighter, and more cost effective than standard two-winding transformers, though they lack electrical isolation between the primary and secondary sides. Based on the operating frequency range, transformers can be classified into three as power frequency transformer, audio frequency transformer, and radio frequency transformer. The frequency of a transformer dictates its core material, size, winding design, and typical applications, as higher frequencies require specialized materials to minimize core losses. First one, power frequency transformers. Power frequency transformer ranges from 50 Hz to 60 Hz. These are the most common transformers designed to operate at standard utility grid frequencies. Core material used is heavy laminated silicon steel core to reduce eddy current losses. It is mainly applicable in step-up and step-down transformers in electrical grids, distribution lines, and industrial power supplies. Main characteristics of power frequency transformers: they are physically large and heavy because lower frequencies require a large core cross-sectional area to handle the magnetic flux without saturating. Second one, audio frequency transformer. Audio frequency transformer ranges from 20 Hz to 20 kHz. It is designed to operate within the audible frequency range of the human ear. Core material used are laminated silicon steel or high permeability mu metal. Application. It is used in audio amplifiers, sound systems, and telecommunication equipment for impedance matching and isolating audio signals. Main characteristics of audio frequency transformer are they must maintain a flat frequency response across the entire 20 Hz to 20 kHz spectrum to prevent audio distortion. Third one, radio frequency transformer. Radio frequency transformer ranges from 20 kHz to 300 MHz. Operating in the radio frequency spectrum, these are used for transmitting and receiving wireless signals. Core materials used are air core or powder iron. Air cores are used at ultra-high frequencies to eliminate core losses entirely. It is mainly applicable in radio receivers, transmitters, TV tuners, etc. The main characteristics of radio frequency transformers are they often handle very low power signals and are frequently tuned using a capacitor to resonate at a specific frequency. Specialized transformers are engineered to handle unique electrical loads, high thermal stresses, and specific voltage current conversions that standard distribution or power transformers cannot accommodate. First one, welding transformers. Welding transformers are step-down transformers that convert high voltage low current electricity into low voltage high current electricity, safe and effective for arc welding. Second one, furnace transformers. Furnace transformers provide power to electric arc furnaces, induction furnaces, or resistant furnaces used in steel making and metallurgy. Third one, pulse transformers. Unlike power transformers that operate on continuous sinusoidal AC waves, pulse transformers are optimized to transmit rectangular electric pulses with high speed and minimal distortion. Fourth one, rectifier transformers. Rectifier transformers are combined with industrial rectifiers to convert AC power into DC power. They are essential for processing like aluminum electrolysis, chemical plants, and DC traction systems. Fifth one, traction transformers. Traction transformers are mounted directly into electric trains, locomotives, or high-speed rail units to step down the high overhead catenary line voltage to a level usable by the train's propulsion motors.